All right, hello there, pre-AP students. This is Mr. Hamilton. I'm recording this video so that you guys can go over the discussion questions on Tuesday when I'm going to be gone. So basically what I'm going to do is just kind of walk you through the questions and go through the answers, kind of show you some things from the text that you should have read last night. So we'll go ahead and get started here. So number one, your question was to write your own definition for the term engineering design process. All of you obviously are going to have different definitions of your, that you came up with on your own. But I think, what it comes down to is that engineering is really just a problem-solving process. And I think if we go to your text from last night that you read, we'll kind of scroll up here to the very first part, but right in here it says engineering design is the process of devising a system, component, or process to meet desired needs. So I think engineering always starts with a problem or a need that needs to be solved, and engineers follow a process that allows them to come up with something or design something that meets those needs or solves the problem that they're dealing with. So that's kind of the general idea of engineering. So we'll go back to our questions here. Number two, the word design can mean many different things. What definition of design was used as the basis for the text that you read last night? So if we actually go to the text that you should have read last night, and we scroll down here, the definition, they talk about the fact that the word design has several meanings right here. And it says one meaning is a plan or drawing that shows the look and function of an object or structure before it is made. And so that's the definition that this whole text is based off of, is the fact that we are coming up with a plan or a drawing that shows, the look and the function of something that is going to solve the problem that we're dealing with. So when we design something, we're coming up with a plan, we're coming up with a drawing, eventually we're going to build a prototype, those kind of things. But ultimately we're designing something to solve a problem, and so we want to have a plan or a drawing to show what that solving of the problem is going to look like. So that's the definition of design that we're working with when we're talking about engineering. Back to our questions here. Number three, what are some of the possible reasons that the EDP or the engineering design process may not result in a viable design? So within the text that you read last night, it talks about the fact that, just like with the scientific method, we often refer to it as the engineering design process, even though that's not necessarily true. There are multiple ways in which engineers solve problems, but we want to talk about, at least one way in which kind of is a general guideline that we can follow. And so we'll talk about what that general guideline looks like here in a second, but I'm going to scroll down to right here where it says the engineering design process may not result in a viable design for several reasons. So even though we have this design process that we're going to follow, there are reasons in which, even following this, you could end up with a design that isn't viable or that isn't going to solve your problem. And so these are some of the reasons right here, these bullet points. Incorrect or unrealistic assumptions. So if you're going into your investigation or problem solving task, if you have unrealistic assumptions of what is to be true, something could go wrong in their process. A lack of understanding of the desired needs or underlying problems to be solved. So meaning you don't really understand what you're trying to do, so you need to make sure you have an understanding of what it is that you're trying to solve. Errors in design specifications or representations. For example, models or drawings. So if your model is not made correctly, or if your drawing is not made to scale, or things like that, that could be a possible reason that something goes wrong. Other reasons, inadequate testing of prototypes. So you have to make sure that your tests are done well and that you receive valid data, valid results from the testing of your prototypes. Otherwise, you may end up with a poor design. And then lastly, just poor design choices. So just maybe not making the time to brainstorm different ideas with different people, come up with the best solution to the problem. If you choose a poor design, then it's not going to solve your problem very well for you. So those are some of the reasons that, even if you do follow the engineering design process, things can still go wrong within your experiment as long, or within your design, as long as if you don't follow exactly what's in the process. So let's go back to our questions here. Number 4 says make a flow chart to show the steps in the engineering design process. So I'm just going to pull up the text again here and show you the flow chart that is within this text. So this is the engineering design process according to the text that you read last night. So it's always going to start with defining the problem. What is it? What is the problem that we're trying to solve? Identifying criteria and constraints. That can be, how much money do we have to do this? How much time do we have to do this? Those are all things that need to be worked out before you can start generating ideas, which is the next step. That would be also, a synonym for that would be brainstorming. Okay? Talking with multiple people, coming up with lots of ideas, writing all those ideas down, exploring those possibilities is the next step. Which ones are realistic, which ones aren't, and then ultimately selecting your design of what you're gonna start actually designing. Okay? Then you develop a detailed design. That could be a plan or a drawing or something like that to come up with your actual design. And then your next step is to create your model or your prototype. Once you have your prototype created, then you can test it and evaluate it, see if it works, collect data on it, and make sure that it's working properly. And if it isn't, then the next step would be to refine your design, go back and redesign a little bit, and then once you have your final design, you can implement and communicate your process and your results. So that's kind of the regular design process that most engineers would follow. And like we said before, it's not a set in stone kind of thing, but it is a general guideline for engineers to follow. So we're going to go back to our questions here. And the last question says, explain the difference between the regular engineering design process and the spiral engineering design process. So we're going to go back to our text again. All right, so if we take a look at our spiral design here, this one looks obviously a little bit different than the other one that we just looked at, but is also very similar. There's one distinct difference in the fact that in the spiral design, essentially you are going back to the drawing board and making changes and developing kind of a new design, and then ultimately creating a new prototype and testing again and refining again. So whereas in the original engineering design that we looked at a little bit ago up here, they basically just tested and then they refined the design and then implemented it. They didn't go back and completely redesign. So in the spiral design process, this would be something where you design it, you test it, you create your prototype, you test it, and then you realize that it's not going to work. And so you essentially go back to the drawing board, come up with a new design, build a different prototype, test it again, and then ultimately, hopefully, just refine that and then implement it and then communicate your process and results. So the spiral one is basically for when we run into a roadblock of this design isn't going to work, we have to go back to the drawing board and make a new one. So that kind of covers our questions for today. I will be back tomorrow, just so you guys know. So if you have questions on the engineering design stuff or about your test coming up in a couple days here, I will be available to answer those questions tomorrow for you. So good luck, and I'll see you tomorrow.